Today's lesson is an extension of the exponential growth that we talked about in the previous lesson. And today we're going to specifically talk about compound interest, which is probably the most important concept in math for you to understand in real life, because those of you who really understand compound interest are more likely to invest your money and you're more likely to have a successful retirement than those who don't grasp or fully appreciate the power of compound interest. So we'll just go through a couple examples and hopefully it'll give you a new appreciation for the power of multiplication compared to adding. And we'll just go through that and I'll explain what I mean. So exponential growth, we saw this function yesterday, y equals a times b to the x, and that's our basic function for exponential growth. Remember, linear models was y equals mx plus b, and now everything's y equals a times b to the x. And what that shows is when a quantity grows exponentially, it increases by the same percent over equal time periods. And to find the amount to which the quantity grows after t time periods, whether it's a year or 2 years or whatever, we're going to use this following model. So here's the formula we're going to use, and you can have this in front of you, and we're just going to plug in the information that they give us, okay? But A is just the initial amount that we're going to start with. And then 1 plus r is this growth factor. We're going to talk more about that in a second, where r, just r, is the growth rate. And then t, that exponent is just how many periods we're doing this for, right? So the first question you might have is, I thought the equation we're using y equals a times b to the x power. Well, it is. So the a still matches up, right? The t, we're just saying, because we're doing times specifically, we're just saying t instead of x. And then the only difference is that instead of just b, we're saying 1 plus r. But that whole quantity is just our b. So the next question you might have is, well, why 1 plus r? Why not just r? Okay? And we'll see that here. So why 1 plus r? Why not just r? And imagine this example, and this should clear it up. So imagine you have $100 in a bank account that will earn 4% interest this year. Which equation will tell you how much you will have in the account at the end of the year? So look at one. In the first one, we're multiplying our $100 just by the 4%. And remember, 4% is 4 cents, which is 0.04. That will give you the $4. That's how much you would make. But what about the $100 that was still in there, right? You'd still have your 100 plus the $4. And so look at the second equation. The 100 plus 1.04, this is 1 plus r, right? The 100, the 104 is our 1 plus r, which is 0.04, right? That gives us the 1.04. And we can just think about the 1 times 100, right? 1 times 100 is your 100. And then 0.04 times 100, that's your $4. So in this case, we're preserving our amount that we started with plus adding that additional $4. And that's why it's 1 plus r and not just r, because we're not trying to figure out just the amount we're adding. We want to know how much money we have now. So we have to include what we already had. That's why we multiplied by the 1 plus r. All right, so now we're going to use this for a couple problems, right? And we're just going to try and apply this exponential growth model. So here's a compound interest problem. Remember, interest is the amount you make on money that you leave in a bank account. And compound interest means you're leaving it in that account and you're multiplying that amount in consecutive years by that rate. So the amount that you have at the end of the first year, you're growing that. And then the amount at the end of the second year, you're growing that. And you're compounding that interest that you're growing. So compound interest is earned on both an initial investment and on previously earned interest. Compounding of interest can be modeled by exponential growth, where A is the initial investment, same as before, right? We're not changing anything. R is the annual interest rate. And remember, we're doing 1 plus R because we want to know not just what we're making, but also what we already had there. We want to add that all together. And T is the number of years the money is invested. So you put $250 in a savings account to earn 4% annual interest compounded yearly. You do not make any deposits or withdrawals. How much will be in your investment in 5 years? And again, all we're going to do is plug in, right? Y equals A, our initial investment, in this case is $250, times what's our rate of growth? It's 4%. But remember, we have to multiply that by 1.0, we have to multiply that, we have to include the 1, so 1.04. And the amount of time is 5 years. And so you can think about this if we wanted to do this out. This is just saying you start with $250 and you multiply it by 1.04, and that's after 1 year how much money you'd have. but we want to know after 5 years. So this would be after 2 years, after 3 years, after 4 years, and after 5 years. And so notice we're just taking that exponent rule that we've talked about in previous lessons, and we're applying it now to this interest rate that we're multiplying by. So this is, again, this would give you how much money you have after 1 year. If you did this, that would be how much after 2, 3, 4, and 5. And if we do that out, we get $304.16. So you'd have $304.16 after 5 years from your $250. Remember, you're not doing any additional work for that. Now you might be saying, well, that's not that much, right? Why would I bother doing that? Well, remember, we only got 4% interest and we only saved it for 5 years. So these are the two things that you can think about as you grow older and you start to invest your money, right? What's that interest rate that you're earning? And then how long are you going to invest for? Because if you change both of those, you can earn more, right? So let's say we just earned 7% instead of the 4%. So in this case, we'd have $250. We're going to multiply that by 1.07. That's a 7%. And we're still going to do the 5 years. And when we multiply that out, we're going to get $350.64. So you can say, okay, well, that's a bit more, but that's still not a ton of money, right? So 250 became 350, but I really want to earn more than that. Well, the big thing you can do is to change the amount of time you invest your money for. So let's say we invested for 20 years. So now we still have 250, and we're going to keep the 7% here. Times 1.07, and instead of 5 years, we're multiplying by 20. And think about down here, right? We would be putting times 1.07 20 times, and each one would be representing another year of growth. So now when I multiply this out, I get $967.42. So now you can see the power of compound interest, right? This is $250 you put in the bank account and didn't do anything with. You didn't put any more money in, you just left it. And because you left it for a long time and you got a decent growth rate, that money turned into a lot more than you originally started with. So you can imagine if you were doing this every paycheck, putting a little bit in the bank account, not just that one-time 250, over a long time, you'd end up with a very large amount of savings in your bank account. And that's really the power of compound interest. And again, that's why it's so important for you to grasp it, because it can really have an impact on your life. So let's leave with this one last thought to show you really the power of multiplying. And again, the reason why this is so hard to grasp is because in most things we do in life, we add, right? We walk a couple blocks and we walk a couple more blocks. We add them together. We go to the store and we buy some milk, and then we buy some chicken, and we add those prices together to get our receipt, right? Most of the things we do, we add together. So we're very comfortable with adding amounts together. We don't do things very often where we're multiplying quantities together. And so we kind of lose respect for how quickly numbers grow when you multiply. But this problem might give you a little more grasp of that. So you place 1 grain of rice on the first square of a chessboard. So it's right here, right? There's our 1 grain of rice. Every day you put twice as many on the next square as the day before. So we're multiplying by 2 every day. So you'd have 2, then 4, right? And then 8. And I'm going to stop here because I'm running out of space, and I think I got 8 there, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. But anyway, so you'd have 16 here, 32 here, 64 here, 128, right? And you're thinking, okay, so great, I have 128, right? I'm not going to have that many. It's never going to grow to be that much. But you have to think about what happened in our bank account, right, when we left it for 20 years, right? As you leave it for a long time, these numbers are going to start to blow up. So let's think about what we're doing here. We started with 1, right? And our equation is y equals a times b to the x. So a is just 1. We started with 1 times, well, we're multiplying by 2 every time. So that's times 2. And then the question is, how many times are we multiplying by 2? Well, there are 64 spots on the chessboard. So we'd have to multiply once, right, to get here, twice, 3 times, 4 times, 5, 6, 7. And if we kept going, we'd have to multiply 63 times to get to the end of the chessboard. We would multiply by 2 63 times. So this, if we expanded it, would say 1 times 2 times 2 times 2 times 2, right? And there'd be 63 2s. And when we multiply that, your calculator is going to give you this number that says this. It's going to say 9.223372037 E18. And what that means, that's just your calculator way of saying scientific notation. So what that really means is 9.223372037 0.00337237 times 10 to the 18th power. And that means you have to move that decimal place to the right 18 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have to go another 9, right? So we would need 9 zeros after that. 1, 2, 3, 4. So I'm going to write that out. So I have 9, 2, 2, 3, 3, 7, 2, 0, 3, 7. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's put in our commas. And that number, oops, right here. That's where, right there. That number, get rid of that one right there. That number is 9 quintillion grains of rice. And that is roughly the same amount of grains of sand as there are in the world. And I know at first you're not going to believe it, but go ahead, do the math. You'll see 9 quintillion. Google how many grains of sand are in the earth, and you'll get about that same number. And that should give you an appreciation for how quickly numbers start skyrocketing when you keep multiplying rather than adding. And that is why you should save your money, invest it in the stock market or somewhere where you're earning interest, and leave it there for a long amount of time, because you can get very rich even with modest amounts that you're investing.